Hey everyone, Dr. Clark here, and in this video I want to introduce you to some principles and major techniques involved in setting up physiological data acquisition systems and software for conducting physiology experiments. But before we get into all of that, what I want to talk about first is what it is that we're generally trying to do when we're trying to quantify physiological processes. And in a nutshell, for studying a lot of physiological processes, one of the things that we're going to be interested in doing is measuring a response of some sort over time. To give you an example of this, we're going to start off by measuring a fairly simple response, which is how blood flow changes in your fingertip over time. Now, in humans, blood flow is a dynamic process that originates in the heart, which goes through, alternating cycles of contraction and relaxation to send blood through the blood vessels and ultimately to tissues throughout your body. And we often measure the speed of these contractions as our pulse rate or our pulse frequency, so the number of pulses through time. But there's more to this story. Not only can the pulse frequency change, but also the total amount of force generated by the heart for a given heartbeat can vary. And so under some conditions, your heart will contract more forcefully or less forcefully. And we can quantify this response as the pulse amplitude. So if I were to draw a crude set of graphs of things that we can quantify about heart function, let me just draw out 3 examples of what my measurements might look like. So on all 3 of these graphs, I've got time on the x-axis. My y-axis is force. I'm just using some arbitrary units. So let's say that over time, my pulse might look something like this. Okay, so that might be my normal pulse rate when I'm at rest. But I could also have a pulse rate that might look something like this. Right? So here, this would be a faster heartbeat. It appears normal, quote unquote. Okay. And my heart rate could also look like this. Right, so here is a larger amplitude. Okay, and we're going to get further into the specifics on this later on in the course. But for now, I also want to note one other thing about blood circulation, which is that the blood in our bodies does not circulate evenly to all of our different tissues at the same time. So our circulation is not uniform. And so, for example, if you've just eaten a large meal and you're pretty relaxed, so you're looking something like this, more of your blood flow in this case is going to be directed towards your digestive system. Okay? And so that's going to help facilitate the absorption of nutrients. It's actually going to mean slightly less blood flow to places like your brain while you're very busy digesting. But in contrast, if you are out walking on the savannah and you happen to see a really hungry looking lion, your body is going to quickly remobilize and redirect that blood flow to your muscles so that you can run away really quickly, as fast as you can. Okay, so let's get back now to the question of how we can measure these types of physiological processes, and more specifically, what do I mean by physiological data acquisition systems and softwares? So the basic principles behind these acquisition systems and software are fairly simple. First off, we're going to need some kind of instrument that can detect the process that we're interested in, so some sort of sensor. So we can think about this as something like a thermometer, so like right here. This thermometer is calibrated such that when there's a change in temperature, so if I put my fingers around the end of the thermometer, there's going to be a quantifiable change in the measurement that we can read with our eyeballs, right? I hope you can see, it's a little small in the video, but you can see the, not real mercury, but the mercury starting to climb up closer to 30 degrees on this thermometer. And temperature is one thing that can be sensed, but you can sense a lot of different types of things. So it's possible to sense light, electricity, force, or pressure. And so this finger pulse transducer that I have right here is a device that is configured to detect pressure, or more specifically, a change in pressure. There's something else that we should notice about the name of this device as well. So it's called a pulse transducer. So what that word transduce means is that this is a device that's designed to take some kind of signal or some information input, and then it's going to convert it or transduce it to some other form. And more specifically, in this case, the finger pulse transducer is going to take the pressure signal from my finger, and it's going to convert that pressure signal into an electrical signal. So, what's so great about that? Well, if we come back to this thermometer here, let's say I wanted to track how my body temperature changes over time. I could do that, right? I could come back at regular intervals with a stopwatch and measure my temperature, and then I could write all that down, like in a little notebook or something. That's easy to do across longer time scales, but a lot of stuff happens too quickly to make that practical. Try imagining writing down that pulse amplitude, for example. So that's where the next part of the system comes into play. Once we've converted our pressure signal into an electrical signal, we're then in a position to connect that to a digital data acquisition system that can collect the data for us much more rapidly. And that's basically what the next pieces of hardware and software are configured to do. So this unit here, this is a Power Lab unit. This is a converter unit that will convert the signal from this pulse transducer into a computer readable form, so we can then digitize and display the output on a monitor. Before we look at the Power Lab in greater detail, I also want to briefly show you the old school way of doing things. So here, right here, I have got a vintage EKG. So this is the piece. There's a piece of masking tape on the front of this thing that says that it's from 1976. So the same basic principles I was just talking about apply with this EKG, except in this case, the tiny electrical signals from your body actually get converted into a mechanical signal. And so there's a little pen in here, and so those signals get converted to the wiggling of this little pen that's set against this piece of moving paper that's right here. So anyway, with the Power Lab and the computer, we're basically accomplishing the same thing. We're just doing that in a digital format instead of in an analog format. So we're now going to take a minute and we're going to plug in this finger pulse transducer, and we're going to turn on the Power Lab and fire up LabChart software and see how to get started recording. We're going to need to go into the physiology lab to do that, so I'm going to put all the details for that process into the next video.